Michael? We're on number 3 or number 3? How would you show where those candles meet given a graph? Alright guys, given these two candles that are burning, and eventually they're going to meet because one's fatter, one's skinnier, this one's probably going to burn a little bit quicker. If we were to graph that on a graph, where would they meet? What do we call that? The intersection, good. And the intersection is also called the what of this system?
Middle.
It's the middle. Good, there's another word that I'll ask you to find. I'll say problem, graph.
Solution.
Say it nice and loud.
Solution.
There we go. That's the solution. That's the meeting point. Okay, off the wall question now. You guys are doing really well with this. If I were to add axes, whereas this is x and this is y, where would this be? What would we measure on this axis right here, the x-axis? What would we compare on here? Take a second and think about it. I'll give you 10 seconds to think about that comparison.
I'm thinking maybe like the x would be like blank 2, since there's blank 1 and blank 2.
Okay? Anybody else? Yes?
35.
Okay? Anybody else? So we know there only can be two things, right? And usually, when we move from left to right here, what's in our farthest column is the independent variable. It doesn't change. What doesn't change is represented by x. So where would that go? Yeah. And what will go on our y-axis? You agree? The length. We'll try to write upside down here. That would represent what changes, which is y. Alright guys, we've got one last question and we're finished with this discussion. The last question is, would any values be negative? Take 30 seconds and write that down. Would any values be negative given this situation? We got about 5 minutes till we wrap up this discussion. Everyone has an answer? There's actually 2 ways to interpret these answers. Alright guys, given this situation up here, would there ever be a chance for negatives?
No.
Okay, let's talk. Michael, you go first. Talk nice and loud.
I say yes,
Why?
because it can be just S, and then it can just be a negative, so yes, and
Okay, let's keep going with that. There's no wrong answer with this. It's how you interpret it. Yes.
No,
Why?
because most likely they will both finish burning at the same time because of the top. I mean, thinner one might burn slower than the thick one because of the height.
Go on the right track, man. You're
I don't think we know.
Talk to me.
Because once it burns out, there's no more, I mean, it would just stay 0. It wouldn't go anywhere below or above.
okay. That's yes.
So negative plus take away.
Okay. Both of your answers are correct. It's really how you interpret it, guys. if it's burning down, how do you represent down with the sign? Contraction, negative, right? So if it's burning down, that's negative. But like you said, Troy, can the candle's length ever be negative? Let me ask you something else. Can you ever have negative time?
No.
Yes.
Yeah.
No.
Okay, we gotta be clear on this. When can you have negative time?
Oh, I don't know, I just knew you can.
Yes, sir.
When, like, the candles start falling all around and stuff.
Yeah, like, that's something like that.
Let's stick with time. Time. How would you have negative time? I'm not saying that you can even have negative time. I'm not saying you're right or wrong. I'm just saying, give me an example of when you could have negative time.
Let's say you owed someone time, like say you had to do something and then you were late, and now you have to owe that person more time off your hands, but you don't have it. You know what I'm saying? Like,
Yes.
Oh,
That makes sense.
Like
So like borrowed time,
like overtime. Like when you go to work and you come in late. Yeah.
that would be negative time.
It's like
How about in this situation? Is there any situation here where we have negative time? Watch this clock. It starts at a certain place, and is there any chance here with negative time? So can our time on our x-axis ever be negative?
No.
That time starts where? And ends wherever, right? How about our length? Can the length ever be negative? Let me get this thing off the screen. There we go. Because it will burn down from a certain height, right? And like Troy said, it's going to go down to what? Burn down to nothing, which is zero. It'll never go past, like seep down through here to zero, right? So in this situation here, where we're looking at this burning down, I can see where you could say the size, the length is decreasing. So it would be negative length going down. But really what we're looking at is two positive variables meeting at solution. And so next time you think about a system of equations, guys, I want you to think about two objects moving until they meet at a certain point. And that's exactly what we're going to be doing today when we continue to solve systems of equations using a graph to find the solution. The solution is that meeting point. All right, what I'd like you to do now, guys, make sure your name is on this paper. Make sure you've got all 4 questions answered. Look over your paper now and check to make sure all 4 questions are answered. Do that now.